Okay, so this is going to be a continuation on our last video, which was the conversion to complete square form. So if we want to convert to a complete square form. So let's go ahead and work through this step by step. So I'm going to work through this step by step. So let's go ahead and work with our example, x squared minus 8x plus 4. X squared minus 8x plus 4. So x squared minus, let's go ahead and we did the example, x squared minus 4x plus 8. I converted those. X squared minus 4x plus 8. So as I work this through, we're going to develop rules for conversion. Rules for conversion. The first rule I like to identify is I like to isolate the x variables. So I like to isolate the x variables. So if I want to isolate the x variables, I'm going to have to subtract 8 on both sides. And I'm going to leave my f of x there. So I'm going to have f of x minus 8, and that is going to be x squared minus 4x. In this circumstance, our next rule is sort of void because of what it is. So I always like to say my next rule is to make sure the leading coefficient is equal to 1. If not, divide through that value. So notice, in our circumstance, our leading coefficient is equal to 1. So we don't have to worry about anything. We can skip that step and go on to the next one. Next step is add the constant to both sides such that you have the perfect square. So this next step is the fun part. So we're going to think to ourselves, I need the perfect square. So I have to add some constant over here on my right. What will the perfect square be? So I know that I'm going to have something square. My first variable, we know it to be an x. We're going to divide this value by 2, so we're going to get negative 4 divided by 2 gives me negative 2. And we're going to square this value, so I'm going to add a positive 4 on my right, because negative 2 squared is positive 4. And x minus 2 times x minus 2 gives you this value. But whatever I do to the right side, I also have to do to the left. Whatever I do on the right side, I also have to do on the left. So now, when I analyze this, I recognize that I have f of x, but I combine my constants, so I have 4 minus 8. On my left side, I have minus 4. And now in my last step is we isolate f of x. We're going to isolate f of x. So if we isolate f of x, we're going to add 4 on both sides. And we're going to get f of x equals to x minus 2 squared, all plus 4. F of x equals to x minus 2 squared, all plus 4. And that is going to be the complete square form. So let's go ahead and try doing this with another example. And if you want to go ahead and pause the video as you work through this, that's fine. So we're going to have 2x squared minus 16x plus 5. So this one's slightly different, so we're going to work through our steps one at a time. The first step we have is that we want to isolate our x's on one side. So I'm going to subtract 5 on both sides of the equation. So now we're going to have f of x minus 5 equals to 2x squared minus 16x. And now we check our leading coefficient and we see, is the leading coefficient a value of 1? And it definitely isn't, because our leading coefficient is a value of 2. So we have to make it be a value of 1, so we're going to divide every single term on both sides by a value of 2. So now I'm going to leave this as f of x all over 2 minus 5 halves is equal to x squared minus 18x. Now we have to add a constant to both sides such that we have a complete square. So we have to determine that complete square form, that perfect square form. So we know this will be something squared. My first variable will be a variable of x, and I know that my next value I'm going to bring down, and I get a minus 4 because we have to divide this value about 2. So I get a minus 4. And next, I'm going to square this. I'm going to square this on both sides. So I'm going to square this negative 4, and I get a value of plus 16. So in order for me to have a perfect square, I'm going to add 16 on the right side, but I also have to add 16 on the left side. So I recognize on my left side, I'm going to have f of x still all over 2. But in order for me to add fractions, I have to have a common denominator. So I have to multiply my denominator by a value of 2 and multiply my numerator by a value of 2. And this really gives me 32 halves. 32 halves minus 5 halves gives me a value of positive 27 halves. So we get positive 27 halves. 32 halves minus 5 halves gives you positive 27 halves. And now I will clean this up a little bit. So I'm going to have f of x all over 2 plus 27 all over 2 equals to x minus 4 squared. In our last step, we have to solve for f of x. So what I'm going to do to make this easy on myself is I'm going to multiply every single term by a value of 2. This term, and this term. And by doing so, I'm going to see that this 2 cancels, so I'm going to have f of x plus this 2 cancels, and I get 27. And that equals to 2 times the quantity of x minus 4 squared. And now I subtract 27 on both sides, and I get f of x equals to 2 times x minus 4 squared, all minus 27. And that, ladies and gentlemen, will be the complete square form. And notice, you should be able to tell that there is a vertical shift, down 27 units, indicated by that negative 27. And there is a horizontal shift to the right, 4 units. And this value of 2, this value of positive 2, indicates the curve is opening up, the parabola is opening up. So in the complete square form, you're able to determine a lot more information, specifically that vertex, which we're going to get into in a little more depth next section.